Hello guys. Yeah, in this tutorial we are going to discuss the question partition link partition list according to Leetcode. So this question actually gives us a linked list and a value x. So you can see in the question what are the input values. Those are a linked list with its x value, and I'm representing it in like kind of that way. But yeah, x equals to 3, and I'll tell you what we can do with the input statements that we can do. Given the head of a linked list, yeah, they will give us one list and the value x. Partition it such that all nodes less than x come before nodes greater than or equals to x. It means they will actually give a value x. So the values that are actually less than x should come before to the x node, and the values that are greater than x, we don't need to care, we don't need to replace them or reposition them, we just need to only reposition the values that are less than x. So in this example, for this example, what he actually gave us x equals to 3. So x equals to 3 means the we will have a node, and x is always a value that is existed in our linked list, and x equals to 3 in this case. So the values that are less than 3 should come towards left side of 3. What are the values that are less than x? They are 2 and this 2. So there are two 2's. Those two nodes should come here and here. And the resultant list should be 1, 2, sorry, the resultant linked list should be 1, 2, 2, 4, 3, 5. We shouldn't change the order of the values that are actually greater than the x. Here, if you see in both examples, not both examples, if you see here, the node 4 is actually greater than x. So 4 is coming in front of 3. So what I told you, if the value is actually greater than x, we shouldn't change the position. So what we have done, we shouldn't change it the relative order. They're actually in the correct order only. In the result, this should be make sure. So this should be the expected output. So how we can tackle this question? So let's discuss the best best way to solve this question, and I'll give you the best path to do this. Yeah. First, you need to create two dummy nodes which are actually the heads of the linked list, and the first linked list, wait, let's assume two dummy linked lists. One is left, sorry, not left. One is before, one is after. Assume that the naming is way more better. I'll help you how why we are naming that way. One is first linked list name is before head, the other linked list name is after head. So these are actually dummy linked list nodes, and we are not creating the entire linked list, we are just creating two nodes and point the nodes with the values using these nodes only. The remaining these nodes are there now. We'll just point the two heads to these nodes only. So we don't need to bother about taking extra space, that kind of thing, because that's not we are doing. We are just pointing with extra pointers only. Just we are creating two extra nodes, and those are actually heads, and then we will finally merge them. So it comes like the first node, the first dummy node, which is actually before head. It means what is actually getting into your mind? Tell me. Before head, what you are getting into your mind? Before head is nothing but the values that should come before head. Here, in this case, we can take head as x, right? Because we are actually making our decisions based on x. So if we actually place the values that are less than x into the before head, then it would be better. Then we can do other part now. The other one is after head. Am I writing this too bad? No problem at all, I guess. You guys can understand what I'm writing. Oh, fuck. Off or a bench of, yeah. These are these are two dummy nodes which are actually kind of representing as a dummy linked list. Not dummy linked list, just dummy nodes. Yeah. These do actually have a dummy values initially. I'll show you in the code. And using these both dummy nodes, we just point the nodes to the other nodes and merge them by excluding the dummy part of the node. So I'll show you that one in the code. So here, before head, what we are considering before head means the values that are actually less than 3. So if we add those nodes into before head, what are they actually? 1, 2, comma 2. These are the three nodes that are actually less than 3 because x is actually 3. So these are the three values that are actually less than x, and we should add it to the beforehand. Then coming to afterhand, we should actually include equals to also. So when we include equals to also, it means x less than x greater if some value is actually greater than or equals to x, then we need to add it to the afterhead value. So then it comes 3, 4, 5, and finally, sorry, my bad. Holy shit. Okay, so those are the values, right? 4, 3, 5. Yeah, 3, 4, 5. Yeah, those are the values. Now if we just merge this, sorry, I had wrote in the ascending order. I shouldn't do this one. My bad, no problem at all. But yeah, we actually no need to care about the sorted sorted manner. They can be anywhere, but the value should the value that is less than should come before the x. It shouldn't come after the x. So we are not about considering about the sorting position. So 4, 3, because you shouldn't actually manipulate the positions except before x. So this should be merged. Then we will get 1 double 2 4 3 5. 1 double 2 4 3 5. Yeah, done. So if we merge this one, it's done. That's it. No problem at all. So we just take two nodes. One is before head, after head, and two pointers for each one. One is for before head and one is for after head. Those pointer named as before and after. Those are the naming that we give for the two pointers. And when we traverse with while loop on the original given linked list, and for every node we will take the value and compare that with x. If 1 is actually less than or equals to 3, then we need to add it to the beforehand and move our head pointer, which is actually the original pointer, root. This is root node, right? Root dot next. Then we are pointing it here, and also we need to move the pointer of the beforehead by 1. Then we actually add a node to the beforehead, not actually creating, we're just pointing. And then we need to move a pointer by not by 1. Yeah, we need to move a pointer by 1. And initially there is nothing there. So now we are here and we check the value with the x. If x value, if 4 is less than or equals to 3, is that true? No, that's not true. So add it to the after head. So we added here, and then we come here and we check, is 3 less than or equals to 3? Is 3 less than or equals to 3? Yeah, that's true. So we'll go and add it here, and then 2. Is 2 less than 3? Yeah, so we'll add it here. Fuck. Wait a minute, I missed the flow. Yeah, up to here it's clear, right? When if value is less than 3, we should, yeah, I forgot the core idea. I actually, now I got the point. If 1 less than or equals to 3, we add it. If 4 less than or equals to 3, no, not equals to. If 4 less than 3, not equals to. You shouldn't compare with less than or equals to. If 1 less than 3, yes, so add. If is 4 less than 3, no, add it to here. If 3 less than 3, no, so add it here. If 2 less than 3, yes, so add it here. If 5 less than 3, no, so add it here. If 2 less than 3, so add it here. So we got things, and we'll just merge them and it's done. That's it. I'll show you in the Leetcode platform how it looks. After this, yeah, the same thing, same description, nothing different. I just copied the description and pasted it there. Simplicity. Yeah. You'll just take two dummy nodes and assign any value. I just like to add the value 18, so I did the two nodes, and then I had taken two pointers for those two nodes. Then use a while loop to traverse on the whole linked list, original given linked list, and then I use if else condition for if head value is less than x, then we need to append it to the before head dummy linked list using the before pointer and the opposite for else case. And in the previous explanation, in that in the explanation that I showed, that I mistakenly told you that less than or equal to, that's the problem. You should keep less than. Okay, so yeah, I figured it out and I done correctly only, no problem at all now. Yeah, that's what I want to make sure from you. And also we need to move the head pointer by one along with this one. So we are at a single line, we are doing outside the if else block, so it works for both cases. And then after dot next equals null. Yeah, I haven't explained you merging thing because there is a small kind of edge case gonna happen if you directly merge, because you need to exclude and merge the value, because as I told you, we actually have the dummy value 18 and 18 before head. Starting value is going to be 8, and in the middle when you are merging, the 18 also includes. So we need to exclude this point and also this point. We can do this one at the returning statement. We'll do it at last line. But this one, how we can do? First, we need to avoid cycle. So to avoid cycle in the linked list, after dot next equals null, it means at the end of the linked list, it actually, there is a chance that the last node may point to the previous node. There is a previous kind of connection, so it leads to the cycle. So we need to break that. So to make sure it works perfectly and no like kind of error free, we need to make it as null after dot next equals null. So we are pointing the last node as null, and that's the end of our linked list. And we're just making sure that it's a cycle, it's not to be cycle. And then to avoid the node as 18 coming into the linked list, we just need to do before dot next equals to after head dot next. Before dot next is actually the pointer of the before head linked list, which is a dummy linked list. So that pointer's end should be pointed to after head dot next. After head is actually 18. 18 dot next is actually the original value, which is a part of the original linked list. So after head dot next actually ensures us excluding this 18 and pointing to the next value. So now we actually reduced this node. I mean, we haven't included this node, but this is still there. This node is actually still there in the linked list. So to exclude this one, we just return before head dot next. Before head dot next excludes this node 18 node, and it returns the next from the next head. What is the node? That node, it will be returned in this line. So if that node is returned, the whole linked list is returned, right? So and that's the end. Yeah.